The purpose of this study is to construct a multi-rotor aerial reconnaissance unit that would help the government and military to respond immediately to the most affected areas of the calamity. This focuses on the development of a multi-rotor system unit which designed with the use of the LabVIEW and Arduino software platforms. The first objective is to implement motor controls using LabVIEW via laptop. This is the host controller of the Maruro. Using LabVIEW as graphical user interface, you can control the motor in various speed. Speed gauge indicator is used to determine the speed value of the motor. There is also digital speed indicator to show the exact speed value. Green LED indicator is used to indicate when the speed of the motor goes up, while the red LED indicator indicates when the speed goes down. XB modules are used as communications in both host controller and the quadcopter unit. By continuously pressing the W key button in the host controller, the speed of the motors increases while the S key button is used to decrease the speed of the motors. 28 to 30 is the starting value for the motors to be able to start. This value can be adjusted by using Arduino programming. The transmission of signal through XB is in real time, so the motors immediately respond to the host controller's command. The second objective is to interface IP camera on LabVIEW. One of the main features of this project is the use of IP camera for surveillance. An Internet Protocol camera, or IP camera, is a type of digital video camera commonly employed for surveillance, and which, unlike analog closed-circuit television, CCTV, cameras, can send and receive data via a computer network and the Internet. You can view the images that the IP camera transmits through the LabVIEW graphical user interface. To communicate with the IP camera, an internet connection to both host controller and IP camera must be established. By accessing the IP address of the IP camera, you can view the live feeding of camera through LabVIEW graphical user interface or to your smartphones. One of the features of the IP camera is the pan, tilt, zoom or PTZ. Using this feature you can view live feeding in any orientation that the user wants. You can also listen to live audios using the IP camera. Since they have different communications that are using, you can control the speed of motor and the movement of IP cameras simultaneously. The third objective is to have an alternative motor controls using an iPad through an iData dashboard. The iPad is a 9.7-inch touchscreen tablet PC made by Apple. The iPad is basically a netbook without a keyboard, which allows it to be smaller and lighter without sacrificing much functionality. An iData dashboard allows you to create custom, portable views of National Instruments LabVIEW applications. Using this application, you can create dashboards to display the values of network published shared variables and deployed LabVIEW web services on indicators, such as charts, gauges, text boxes, and LEDs. For controlling the motors using an iPad, the iPad must be synchronized correctly to host controller through shared variables that has been included in the main VI. The data dashboard can be customized by the user. This includes motor controls and speed indicators. Increase and decrease buttons are used to vary the speed of the motors through data dashboard. There is also a speed gauge indicator used to show the speed of the motor. The last objective is to interface Google Map on LabVIEW for GPS tracking. GPS tracking in Google Map using LabVIEW graphical user interface is also one of the main features of this project. The Global Positioning System, GPS, is a space-based satellite navigation system that provides location and time information in all weather conditions, anywhere on or near the Earth where there is an unobstructed line of sight to GPS satellites. In GPS tracking, an internet connection in the host controller must be established. To track down the location of the quadcopter using Google Map, there must be unobstructed line of sight for the GPS antenna to communicate with the GPS satellites. The user can view and navigate the Google Map using the LabVIEW graphical user interface in the host controller. The user can also know the coordinate location of the quadcopter with the help of the GPS through Google Map.
Lumilipad na naman ang isip ko
para mga may nasa kalangitan.
Sa tuwing sinumaray, aking matitignan. Lumilipad na naman ang isip ko
Para mga may nasa kalangitan.
Sa tuwing sinumayay, aking matitignan.
Ang simay ng hangin sa akin ay lumalamig na.
Ang simay ng hangin sa akin ay lumalamig na.
Ang simay ng hangin sa akin ay lumalamig na.
Ang simoy ng hangin sa akin ay lumalamig na. Shotgun, shotgun, ganja, ganja, Buddha, Buddha.
Buddha, Buddha, Buddha.
Shotgun, shotgun, ganja, ganja, Buddha, Buddha.
Buddha, Buddha, Buddha.
mga oras na kasama ka, mundo ko ay nag-iiba. Problema di napapansin, sumasaya ako sa tuwing kapiling ka na parang lumulutang ang isipan. Sa kalawakan at ako'y nalilimutan, suliranin at ang mga kabiguan. Tawanan at tawanan lang at ilabas mo na rin ang pagkain na dihain na ang malamig at tubig na papawi sa panunuyo ng lalamunan. At sidihan muli natin ang mahiwagang dahon na nagbibigay ng kulay sa mga bagay nagpapapungay. Sa aking mga mata na darama ko ay kakain.